Hi guys! Let's begin with a new video, Confusion Matrix. In the previous video, we looked at logistic regression and naive Bayes classifier. In this video, we are going to look at the confusion matrix, understand its terms, create and visualize a confusion matrix. A confusion matrix is a figure or a table that is used to describe the performances of a classifier. It is usually extracted from a test dataset for which the ground truth is known. We compare each class with every other class and see how many samples are misclassified. During the construction of this table, we actually come across several key metrics that are very important in the field of machine learning. Let's consider a binary classification case where the output is either 0 or 1. True positives. These are the samples for which we predicted 1 as the output and the ground truth is 1, 2. True negatives. These are the samples for which we predicted 0 as the output and the ground truth is 0, 2. False positives. These are the samples for which we predicted 1 as the output, but the ground truth is 0. This is also known as a type 1 error. False negatives. These are the samples for which we predicted 0 as the output, but the ground truth is 1. This is also known as a type 2 error. Depending on the problem at hand, we may have to optimize our algorithm to reduce the false positive or the false negative rate. For example, in a biometric identification system, it is very important to avoid false positives because the wrong people might get access to sensitive information. Let's see how to create a confusion matrix. Create a new Python file and import these packages. Define some sample labels for the ground truth and the predicted output. And create the confusion matrix using the labels we just defined. Visualize the confusion matrix. In this visualization code, the ticks variable refers to the number of distinct classes. In our case, we have 5 distinct labels. Let's print the classification report. The classification report prints the performance for each class. Let us run the code. You will see this output. White indicates higher values, whereas black indicates lower values, as seen on the color map slider. In an ideal scenario, the diagonal squares will be all white and everything else will be black. This indicates 100% accuracy. You can see the printed output values here. Great! We learnt about the confusion matrix here. In the next video, we will look at support vector machines.